Welcome to the video of network redundancy using Hsrp. I myself Anil Patel with my colleague Meet Patel will guide you how Hsrp ensures seamless network failovers. In this video, we will cover what is network redundancy, why it is important, what is Hsrp, how it works, what are the key features, real life application of Hsrp, benefits of using Hsrp, and a practical demonstration of Hsrp using Cisco packet tracer.
So, what is network redundancy? Network redundancy ensures continuous availability in case of failure. It involves using backup device and link to maintain uptime. Redundancy minimize downtime and prevent data losses. Used in enterprises, network, data center, and ISPs. So, why network redundancy is important? Ensure business continue in case of hardware failure to prevent single point of failure, reduces latency by optimizing traffic flow, essential for mission critical system like hospital and financial institution. Introduction to hot standby router protocol. HSRP is a Cisco priority protocol for router redundancy. It provides a default gateway failover mechanism, allow multiple users to share a virtual IP address, ensures automatic failover in case of router failure. Working of HSRP. The router with highest priority become active router. Default priority 100, higher value takes precedence. If router have the same priority, the one with the highest IP wins. Framed option ensure the most qualified router take over. What is active router? Handles traffic and forward packet. Standby router. Wait to take over if active router fails. Virtual router uses a shared virtual IP for seamless failover. Hello message. Send message 3 seconds for monitor router status. Now from on this onward, Anil will continue.
Understand Hsrp router state. Basically, there are six Hsrp states. The first one is the initial states. When the interface goes in the up states, it is known as in the initial state. After that, it is the learn state. In this state, the router is trying to learn the virtual IP address. The IP address is known by the router in the learn state. Then after it is the listen state. The listen state router knows the virtual IP address. Now the IP address is known from the learn state, and then it listens for the hello messages from the active and standby routers. Then after it is the speak state. After listening the hello messages from the routers by with the help of the IP address, it is gone in the speak state where the hello messages coming from the routers are participating in election to become the active router. Then after it is the standby state. In this standby state, the router which is in the active mode and will continuously send the hello messages to the active router. Then after in active state router which will receive the data intended to for virtual IP address. The IP address that is inserted from where we will get the reply. It is known in the active state. HSRP is not only the uh, redundancy network. There are also VRRP and GLBP, where VRRP stands for Virtual Router Redundancy Protocol and GLBP stands for Gateway Load Balancing Protocol. Now let's compare all these three protocols. First of all, the HSRP is developed by the Cisco and JLBP is also developed by the Cisco, while the Virtual Router Redundancy Protocol is developed by the IETF, which stands for Internet Engineering Task Force. The standardization of the HSRP and GLBP is proprietary, that is from Cisco, while talking about the VRRP, it is open standard, which contains RFC 376 at model. Virtual IP addressing is available in all three protocols. And talking about the next active and standby, there is in HSRP there is one active and one standby. And talking about VRRP, it is like one master and multiple backups. And for GLBP load balancing among multiple routers, there are multiple routers, and from one there will be performing load balancing. In load balancing, HSRP does not give this feature. Also, VRRP does not have this feature, but GLBP provides load balancing features. Preemption is available in all of the three protocols. That means we can switch to another state while the process is going on. After that, authentication is also provided by all the protocols. And default hello timer for HSRP is 3 seconds, VRRP is 1 second, and GLBP is 3 seconds. And the default hold timer after the hello message is delivered for HSRP it is 10 seconds, VRRP 3 seconds, and GLBP it is 10 seconds. So as we can see that HSRP and GLBP provides 10 seconds for the default hold timer, while as for the VRRP it is only 3 seconds. Now, talking about the network topology, in this demonstration, we will use Cisco Packet Tracer for demonstrating the HSRP protocol. For this, we have used two routers with HSRP protocols, a switch, three pieces for receiving and getting the replies, and a virtual IP for redundancy and failover of the network. Now we will configure the network. First of all, configuration of the PC will be done. Here we have used three PC 0, 1 and 2. The IP address of PC 0 is here, is as you can see that it is 192.16.0.20. For the PC1 it is 192.168.0.30, and for the third PC is 192.168.0.40. The subnet mask for all the PC are 2555 0.255, and the gateway for all this PC is 192.168.0.1. Now configuration of the routers, we have used here two routers, router 1 and 2, and their IPs are 192.168.0.2 and the other one is 0.3. And here virtual router, as you can see that it is not connected. Here it is only used for a failover in the network. Now let's move. Now here is the IP addressing thing. As we discussed in the previous slide, the IP addresses of the routers and PCs were mentioned in the diagram. Here is it is given in the tabular form for your better understanding. Router 1 it is zero point 0.2, for router 2 it is zero point 0.3. The virtual IP that is used for the any failover in the network it is 192.168.0.20, sorry, 0.1, and for the three pieces here it is, and the default gateway is 192.168.0.1, that is of the virtual IP that is used for a failover. Now we will move on the execution of the ping commands on the PC 0 when there is no connection established with the PC and the router due to the port down. When the ports are functioning and we can establish the connection, then the ping reply from the virtual IP that is used, we can't get any reply. As you can see that from the PC 0 we have ping 192.168.0.1. Here pinging, as we can see that there is a loss, 100% loss. That means that no reply is being obtained from the virtual IP. As you can see for also the PC 0 to 0.2 network and for 0.3. Now we will activate the ports and by configuring the router. Here is the a demonstration how the router 1 is activated. So no, then router is enabled, router 1 is enabled. Then interface fast Ethernet 00 is activated, no shutdown. Then IP address is added 192.168.0.2 and its subnet mask is given 255.255.255.0. Similarly, well, now we will activate the router 2. Router is enabled, configure, then interface fast internet 00, no shutdown. IP address is given for here is 192.168.0.3 and subnet mask is same and no shut. This means that both of the routers are now activated. Now the final network diagram is shown here. As you can see that we have used three pieces 0, 1 and 2 with their IP address as displayed here and a default gateway of 0.1, which is our virtual IP, and two routers. Now, as you can see, all the connections are successfully established, and we can now get the reply from any PC to from router via switch. Now, after activating router 1 and 2, we can see that reply is getting started. As you can see, ping from PC0, ping 192.168.0.2, that is mean the reply is expected to come from the router 1 because of the IP address here it is 192.168.0.2. So you can see that reply from router 1 has getting started, and we have successfully obtained the reply. Now we will expect that router 2 will also send the reply similarly as we done with the router 1, and after writing the command we can see that successfully all of the replies are obtained, as you can see here. But not from the virtual network. Here, our virtual IP is not connected. It is serving as a failover network, failover router. Failover. If there is a failover of the NA2 router 1 and 2, then with the help of this router, we can successfully establish the connection. But here in our scenario, the ports are now activated. No port is down, so we can't get any reply from that. Similarly, now writing the command ping 192.168.0.1, that is the gateway for our PCs, we can see that no replies are getting. This means that there is no network failure for the current scenario. Now moving on to the next slide. When our router 1 is down, it means it goes to the standby state. Then with the help of our virtual router, the network establishment is done and reply can be obtained from them. This means that if our router 1 is failed, therefore the router 1 which was earlier in the active mode will go into the standby mode. As you can see here, first of all in the initial state the router 1 was active. Then after shutting down of the router, we can see that line protocol in the internet fast Ethernet 00 changed state to down. This means that our router 1 is down. So there will be no network connectivity with the router 1 now. So now our virtual IP comes into the picture. Now we will establish its connection via router 2. So now router 2 will be accessed by writing the command the standby. We can see that pass internet 00 group 1 state is initial interface down, virtual IP address which was our router displayed in the previous diagram here 192.168.0.1, and hello time 3 seconds, hold time 10 seconds as we discussed it earlier. Next hello sent in 1.1 in second. As we can see that our hello is successfully delivered. Preemption is disabled, so we can't preempt, which means that we can't switch it to other process while any process is ongoing. Now configuration no shut into passing it into state to up. Router 2 is up, and which was earlier in the standby and has gone into the active state as shown here as standby to active. Now, as we know that our router 1 is down, so the network connectivity the router 1 with the switch and the PCs is disabled. As you can see in the diagram, there is red arrows on the connectivity, which means there is a network failure in our network. So now our PC will be getting the reply as our gateway is secured, even though the router is failed. Here, what does the sentence means that even though we have lost the connectivity to the router 1, but with the help of the virtual router and virtual IP, we can successfully get the replies due to the HSRP protocol, which clearly states that if there is a network failure with the help of the virtual router, we can on successfully execute the process of the connectivity. So now writing the command ping 192.168.0.1, we can see that the replies are getting started. As you can see, there is no direct connectivity, but due to the HSRP, we are able to get reply from that, which was earlier not possible.
So, benefits of HSRP. ensure high availability in critical network, prevent the downtime in case of router failure, seamless failover, ensures no packet loss, improves network reliability with automatic recovery. Real world application of HSRP. Enterprise network like bank, e-commerce and cloud service. Data center ensures uptime for critical application. Internet service provider ISPs to maintain continuous connectivity. Government and military network for reliability. Challenge and limitation of HSRP. No load balancing. Only one active router. Standby router remains idle. Cisco priority. No supported on non-Cisco devices. Failover delay. Default timer 3-second hello, 4-second hold can cause downtime. Single gateway per group limits flexibility in large network. CPU and memory usage. Continuous hello message consume resources. Complex configuration. Multiple VLANs require separate HSRP groups. No native load sharing. Unlike GLBP, HSRP does not distribute traffic. Moment packet loss. Some latency during failover. IPv6 support only in HSRP v2. HSRP v1 does not support IPv6.
In the conclusion of the video, we can say that HSRP ensures high availability by providing a backup gateway in case of primary failure. Second point is it operates in the active and standby model. As in the demonstration using Cisco packet tracer, we saw that the router is going into active to standby and standby to active, which helps in improving the network reliability but lacks in load balancing. The third point is failover time can be optimized by adjusting timers. By adjusting a timer, the failover time can be optimized, but some packet loss may occur, as we saw in the message that the packet loss was earlier 100% when the virtual IP was not connected. After that, we successfully recovered that, but here it states that some packet loss may occur when the failover time is more. So we have to take sure that we got optimized result. The fourth one is Cisco proprietary protocol limiting limiting interoperability with the non-Cisco devices. The non-Cisco devices will not be able to see these features. The fifth point is for advanced redundancy and load balancing, we can use the GLBP is a better alternative. Despite of this limitation of the load balancing with the HSRP protocol, it is widely used in companies and enterprises for its simplicity and reliability. HSRP is easy and effectively helping for ensuring zero network failure due to its active and standby configuration. So, in conclusion, we can say that a well-configured HSRP setup enhances network uptime, minimizing downtime, ensuring smooth business operation.